Hello everyone, I'm Yi Tongmeng from the Chinese University of Hong Kong. Today let me introduce our paper PMD, an optimal transportation-based user distance for recommender systems. Today we're going to consider a very fundamental question, measuring user similarities. This is a fundamental problem because, for example, in nearest neighbor-based collaborative filtering, you got to use some measure to measure the similarity of users and then retrieve the most similar ones. The background on this topic is that most previous measures, such as cosine, Pearson's correlation coefficient, they often assume that two users have to rate some common items, and they compare the ratings on the common items or correlated items, and ignores the ratings on the non-correlated items. Although some recent techniques such as BCF consider the ratings on the non-correlated items, but it is using some heuristics. So in this paper, to tackle the drawbacks or limitations of the previous work, we propose the preference movers distance, which is a principled method. Okay, our contribution is threefold. The first merit of PMD, which is our preference movers distance, is that PMD can exploit all the ratings made by each user and works even though the users do not share common rated items. The second point is that PMD is a metric. It has nice properties such as zero self-distance symmetry and a triangle inequality. And also we did extensive experiment to show the superiority of our method. It outperforms the state-of-the-art user similarity measures. Preference movers distance is the distance measuring two users. Actually, the core inspiration of PMD comes from the Earth movers distance or the Waterston distance. The Waterston distance is a distance metric for distributions. It measures the distributions, the distance between two distributions. Recently, the Waterston distance is hot because some interesting applications such as Waterston GAN and so on. But today we're going to apply this distance on the recommendation area. To build up the distance, we got to do some preparation. First, we got to represent each user as a distribution by normalizing his ratings on all his items. Then we need to derive the distance on all the items by utilizing some stat information. For example, movies in the same genre may have smaller distance, and movies in different genres may have a larger distance. Then the formal definition of the PMD is defined as this. Okay, here, PU and PV are the preference distribution of user U and user V respectively, and their distance is defined as a weighted average of the distance among the items that they rated. Here, W is the weighting that we need to learn, and D is the distance among the items which is computed beforehand. So we take the smallest value among all possibilities. And the weighting coefficient W have to satisfy some constraint. The constraint is that the marginal distribution of W have to satisfy PU and PV respectively, and the total summation of W should be 1. If you are familiar with the Earth movers distance, you will read this equation very easily. For efficient issue, we used the sinkhorn algorithm to speed up the computation of PMD, resulting in a time complexity of Q square, and use HNSW to speed up the KNN search, which results in a time complexity of O log n. These techniques can improve the computation of our algorithm to a large extent. For experiments, we did experiment on two well-known datasets, which is movie length and opinions. And here is the data statistics of the two datasets. For item distance, because we got to use item distance to build up the PMD. For item distance, we use side information to evaluate the distance between items. For movie length, we compute movie similarity based on tag genomes, which is a well-developed method for computing movie similarities. For opinions, we extract the comments on items and use doc2vec the method to compute the distance between the items. We compare our method with the previous methods such as cosine, Pearson's correlation, Jaccard, and recent proposals such as BCF, HUSM. The experimental results shows that our method, PMD and CPMD, has a better performance than all of the previous methods, possibly because our method can exploit all the written information on all the items, and we can also incorporate the side information on the items. For more details of the model and our experiment, please refer to our original paper. Thank you very much.